This is part 2. I'm going to again show some examples on DeltaMath of basic proofs of triangles. So here's our next one. So on this information, we are given the following, that DB, which is a segment, so this side, DB, bisects this angle. So if we look at the picture, so this side right here cuts that angle into two equal angles. Okay, that's what bisects means. Now, it's not shown on there, so we need to say that. All right, which is basically just what the definition of bisect means. If you bisect something, you cut it in half. All right, now we've also been given that A and C are congruent, and that was just outright given to us. So we always start with that as step one. So we know that DB bisects that. So what that means is that those two angles are congruent. And then down here, we know that those two angles are congruent. So I'm going to start with my angle congruence. And I can't just name this angle B because there's three different angles up here. There's this little one, and then the whole one. So I'm going to call it ABD. So ABD is this one right here. And I know that that is congruent to CBD, which is this one right here. And the reason why I know that is because that's what bisect means. So an angle bisector divides an angle into two congruent angles. That's what I'm looking for. All right, so let's insert that. So now we know that those two are congruent. So looking for a third reason. I don't know anything about this outsides. I don't know anything. I don't know that D is in the middle, but I do see that these triangles share side BD. So anytime two triangles or any two shapes share an equal or congruent part, then they're going to be congruent. So I'm going to say that BD is congruent to BD, and that is reflexive property. All right, so let's mark that. All right, so now I have that these two triangles are congruent, and remember we have to go in order. So this would be angle, angle, side. So I want my triangle statement. So ABD matches up with CBD, and our reason was angle, angle, side, because that's what we proved. So let's submit that part and then verify, and there we go. All right, new problem. Okay, so let's see what information we have here. Okay, now these triangles are not lined up, but here we go. Let's go for it. So we know that AE is parallel to FD. So AE is parallel to FD. Okay. We know that BF is parallel to EC. So this piece is parallel to that piece. Wow. All right. And then we know that AC is congruent to BD. So AC, which is that side, is congruent to that side. Okay. All right. So here's what's going to happen here. This one's a little weird. So we know that those two sides are parallel to each other. If those sides are parallel to each other, then AD is serving as a transversal, which tells me that this angle up here would be congruent to that one right there. So if these were slid over to match up with each other, because we know AC is the same length as BD, so if we could just shift this triangle over here, then we would have parallel lines with transversal. So I'm going to start right here. So this angle, which I want angle statements. All right, now I can call this angle A because it's the only angle A, and I can call this one angle D, and those are alternate interior angles. Even though they're separated, they are alternate interior angles. So I now know that those two angles are congruent. All right, now in a similar way, so we still know that this side is also congruent. So we have an angle and a side. All right, now going the opposite direction, if these are the parallel lines, so here's EC and BF right there. If we slid these over again, then this right here, this angle, would be alternate interior with this one. All right, so I need my angle statements again. All right, now I don't want to call this angle C because this out here is also angle C. So I'm going to use ECA. So this angle right here is angle ECA, and it is congruent with FBD. So ECA right here is congruent to FBD, and those again are alternate interior angles. So let's mark those. All right, so now, and again, it's not marked because it's not going to look right, but AC is congruent to BD. So if I hover over that, those two pieces are still congruent. So we have angle, side, angle. So if we go to our triangles, and we're going to say AEC and BFB, and we said this was angle, side, angle. So insert that in there and submit our answer, and we're good to go. All right, let's see. Oh yeah, this is what, let's get some with perpendicular here. All right, so this is a crazy picture as well. All right, so let's focus here. We want triangle ADB. ADB. Okay, so it's this big one right here, which is overlapping with BCA. So we have the two triangles that are overlapping. So it's this all the way down here with that one all the way over there. Okay. Now we know AD is perpendicular to DB. So that tells me that this right here is a right angle. And then BC and CA, so that one right there is a right angle. And then they told us that AD and CB are congruent. All right, so that's our given information. Now, what I want to say is that this angle right here and this angle are right angles. So I want to say that angle D is a right angle, and that's because it was perpendicular lines make right angles. Okay. Now, I need to say this one, which is angle C, is a right angle. So angle C is a right angle, and that's for the same reason, because perpendicular, when it says perpendicular, that means that we have right angles. All right, so now we know that C and D are congruent because all right angles are congruent. All right, so now we have a side and an angle, and we now know that these are right triangles. So if you remember right triangles, we have that hypotenuse leg, and it just so happens that side AB is used in both triangles. Oops, I forgot to do that. So, okay. So now I'm going to use my segment, and I want to say that AB is congruent to BA, and that's reflexive property. So if we submit that, so now we have a hypotenuse and leg of this right triangle matching up with the hypotenuse and leg of that right triangle. So we are done. So let's get our triangle statement. So ADB and BCA. All right, so now our reason is hypotenuse leg. So we're going to oh, hold on. Oh, hold on. Okay, let's go back. It's telling me we can't do that yet, so hold on a second. So we need to classify a triangle first. Yikes. Okay, so ADB is a right triangle, and it has a right angle. This is kind of dumb, honestly. Okay, classify So now we want to say BCA is a right triangle because it has a right angle. Yeah, I would never write this in a real proof, but that's okay. Okay, so now let's try it again. Okay, so now we're going to say ADB is congruent to BCA. So, oh, there we go. Now we can see them. So that triangle is congruent to that triangle. And now, try this again. HL. There we go. Thank you. All right, so now, that one was ridiculously long, unnecessarily. But, so that one shows you one with right triangles. All right, let's see if we have time for one more. Okay, here we go. All right, so let's figure out, we are trying to show that BAE, so this left one is congruent to this one down here, okay? And they've given that AB and AD are congruent, so we already have that, so that's that one right there. And then we know that those two are perpendicular. Okay, perpendicular would tell us that they are going to be right angles. So this one is similar to what we just did. So we just need to go through all these steps. All right, so first thing we need to do is say that AEB is a right angle because those are perpendicular. All right, and then we know DEA, which is this one, because those are perpendicular, so we have those two. All right, so now we can say that AEB is congruent to DEA because all right triangles are congruent. All right, so now we have that in there. Okay, so again, we're dealing with right triangles. So I guess we need to go ahead and say that these are right triangles now. So this is really absurd. So let's see, AEB is a right triangle because it has a right angle. Okay, and then DEA is a right triangle because it has a right angle. Okay, so now we know that these two are right triangles. So whenever we have right triangles, we can do hypotenuse, leg. We have the hypotenuse of each one. We need a leg, and AE is a common side for both. So I want segment. So AE matches up with AE, and that's always reflexive, so we can mark that. And so now I think we took care of all of the requirements. So we knew that these were right angles because they were perpendicular, and that's a right angle, and then we knew those were congruent because all right angles are congruent. Then we know that's a right triangle and that's a right triangle, so then we used reflexive property. So now we can declare that our two triangles, which are BAE and DAE, are, hypotenuse leg triangles. So let's fill that in and submit, and we got it. All right, so that gives you a couple more examples using DeltaMath to write proofs.